Now we're going to talk about angles and directions. So we worked with angles so far, but mostly we've looked at horizontal distance measurement. We looked at elevations and grades. And we've seen angles in terms of how do angles help me determine what the slope and the horizontal, how to make corrections, all of that stuff. However, there's a very important part of plane surveying is looking at the direction of a line. So how is the direction of a line defined? It's going to be described by the horizontal angle it makes with the reference line or direction. So, and we're going to talk about what that means. So to understand what that means a little bit better, we're going to talk about meridians. So I just talked about a reference line or direction. So meridians are what's used most often. So there are three different types of meridians: astronomic, magnetic, and assumed. We'll talk about them briefly. So an astronomic meridian is the direction of a line passing through the astronomic north and south poles and the observer's position. You've probably heard of astronomic north. Astronomic north is based on the direction of gravity and the axis of rotation of the Earth. So if you're here, you have your astronomic north pole, astronomic south pole, and this is your meridian right here. Now, this is not to be confused with magnetic north or with your magnetic meridians. So astronomic meridians should be used for all surveys of large extent, and in fact, they're desirable for all survey and land boundaries because they don't change with time and can be reestablished decades later. They're very reliable. Meridians continued. So another meridian is your magnetic meridian. So that's a direction taken by the magnetized needle of a compass from a specific position. So magnetic meridians have been used for a long time. Actually, compasses have been used for a long time. And it's actually quite cool that if you think about it, the Earth kind of comes with its own way of navigating. So before most of the things that we use nowadays were possible, people have been using compasses, and we're going to talk about that in a little bit. However, there's a big problem with them, and that's that they are affected by many factors, and that means that they change. So your magnetic poles don't stay the same way. They actually move a little bit, and they get and your compasses are susceptible to things around them. But in any case, they are easy to find. They're easy to get because, a compass, your phone has a compass, So anyway. And then we have assumed meridians. So assumed meridians is an arbitrary direction taken for convenience. So we're going to talk about assumed meridians when we talk about traverse, because as long as you, like for consistency, whatever you choose to begin with doesn't matter, because it's all going to, especially with closed traverse, it's all going to kind of have to work out in the end back to where you were. So it's just a point of reference, a made up easy point of reference that helps you find all of the intermediate points and all of the intermediate angles. So the disadvantage is that if you lose the point you started working from for whatever reason, that means that you are in trouble. So anyway, now let's talk real quick about units for measuring angles. So obviously degrees is what you might be coming to mind, but before we talk about degrees specifically, even degrees have different ways of being written down. One of them is with sexagesimal. So we've talked about this before, that when the circumference of a circle is divided into 360 parts, this is degrees, which are further divided into minutes or seconds. Now, we know that this number could also be like 32 point something, but in all honesty, this is what's used in surveying most often is minutes and seconds notation, and it's a good idea to start getting used to that as much as possible. We're actually going to work on doing some subtraction and addition with this. So yeah, that's what the NGS uses. Then we have the centesimal system. Now, this one's used in Europe and other parts of the world. It's really not used so much here in the United States, but it's important that you know it exists, just so that whenever you stumble upon something that says a grad or a gone, that you don't completely freak out. So pretty much what they do is they chose that the circle is going to be divided into 400 parts rather than 360, and therefore 100 gone are equal to 90 degrees. Does that make sense? So imagine your circle divided 4 equal parts, 400 divided by 4, 100 each, and each quadrant will have 90 degrees. It used to be called grad, now it's called Lagrange. Don't ask me why. Okay, then we have radians. So radians are unitless, and that makes them really cool for doing math and stuff. One radian is an angle at the center of a circle whose arc is equal in length to the radius. So pretty much it's a ratio, and pretty much a radian is equal to 360 divided by 2 pi. So approximately 1 radian is 57.30 degrees. And what's super important about working with radians or degrees is that your calculator can be toggled between radians and degrees, and it's important that you notice whether you're in radians or degrees, because if you're working with degrees and your calculator is in radians, you will get incorrect answers. So just watch out for that. So here we go. That's a picture that should help. Okay, so we're going to talk about azimuths and other things over in the next video.